So my name's Leo Bicknell, and I work for ISC, but today I'm wearing a hat as an ARIN AC member. And I thought, since everybody's always concerned who you work for, we should make that official. ARIN actually has hats, so it makes it much clearer who you're working for. I'd also like to thank Cathy, our previous presenter. She did a lot of work helping me get this together, so she deserves just as much credit. Someone once told me you needed really good quotes in your presentation, and I found some really juicy ones you'll find as these slides go on. I'm not really going to read them. I'm going to let you get your own amusement, and you are welcome to chuckle out loud when we switch to a new slide. If you've been to a NANOG meeting recently and know you're not expected to read all those, there are 7 years of IPv6 presentations. We started in June of 2000. And best I can tell, particularly from Cathy's previous presentation, we're not quite getting the uptake we'd hoped for. I think that message is loud and clear. So, clearly there's some worry about what's going to happen. We look at the usual excuses, right? You're going to deploy it when somebody will pay for it. Y'all in business to make money. And you all have the same problems. Hardware doesn't support it. Network management tools don't support it. Too busy doing other things, customers won't pay for it. Everybody's got an excuse as to why they're not doing IPv6 yet. And that's fine. But as you start looking at this, what happens if you can't get IPv4 addresses anymore? This has been alluded to in several of the other presentations, and what we really want to do here is kind of spell out some doom and gloom, but in an Addams Family tradition, do it in a very humorous and fun way, which is why we have a panel up here, and talk about what happens on the v4 side of the network. So I'd like to predict the death of the internet, but I'm an engineer and I know that's not actually going to be the case. Hence we get the title of this presentation, The End of the World as We Know It. Jeff Houston, who you've heard speak already, has wonderful information. His website URL is there. I highly recommend, if you've never looked at it before, you need to read this. As you can see, I have lifted his figure 30D. There's probably at least 100, if not more, figures there. He has data on everything you might ever want data for. But for this discussion, this is the relevant slide. He has mathematical models that you may or may not believe that predict when we will run out of IPv4 space. The red line on this slide is the IANA free pool. And as you can see, it trends downward, as everyone knows it will. And his current mathematical model predicts that it will run out in April of 2010. The green line represents the free address space held by RIRs. RIRs, just like ISPs, allocate space for a little while and then go back to IANA and get more. So there's this little sawtooth pattern that goes on. And they can keep doing this as long as they can keep going back and getting more. And then when IANA runs out, they run out a little bit later. And you can see that in the green line. January 2011 is the actual time from that graph. There's another thing to look at after that he didn't have a direct graph of, and that's when an ISP would run out. And there's kind of two different ways to look at this. If you want to look at it from an average perspective, ARIN's policy states that we should be providing 6 months of free space to ISPs. So on average, 3 months after that, you'll run out. However, if you're the guy who asks for space the day after ARIN runs out, you're going to be out that day. You might also be the guy who asked the day before, in which case you'll have 6 months. If you're that lucky, we're out to August 2011. However, there's a big if here. Actually, two big ifs. First of all, this does not account for what we all call the run on the bank. Everybody knows from savings and loan crises and all sorts of other things where there's not enough to go around, that eventually everyone in this room, quite frankly, is going to wake up and say, oh my God, I'm not going to be able to get more tomorrow. And they're going to find whatever way they can to get it today. So almost certainly, these predictions are optimistic, and the date will be somewhat sooner. It may only be 2 or 3 days sooner. Maybe we don't notice until the last minute. Hopefully with presentations like this, the run on the bank occurs sooner. Is that actually a good thing? The other thing it doesn't account for, and this may be relevant to some of the people in the room, is prefix size. You may go to an RIR in this period where they still have space and say, I'm a really big ISP. I'm going to go deploy, millions of cable modems. I'd like to get a /12. And the RIR may look at you and go, well, yeah, your paperwork's in order. That sounds pretty good. But, we don't have that. So how about 3/18s and 14/19s? And yeah, we scrounged up a /20 in the corner, and it's not all you wanted, but you'll have to make do. What are you going to do with that? So the reality is, wait, it might be true. The world as we know it might end. We might not get to V6 fast enough, in fact, almost certainly, to get away from IPv4 before we run out. The question is, how far along will we be? And then you also have to look at what exhaustion means at each level. Because clearly, the day IANA runs out, it doesn't stop the internet from working. The day an RIR runs out, it doesn't stop the internet from working. The day an ISP runs out, it doesn't stop the internet from working. However, it may mean that you can't increase your revenue anymore, which may mean a couple of months later you go out of business, and then your piece of the internet stops working. So there are some alarmists among us. They're called ARIN board members. They decided to incite panic and released a press release saying just this: we're going to run out of this stuff. And I do give them some credit. They were fairly forward-thinking. They analyzed Jeff's data, looked at their own stuff, actually got together and made up their mind on something. So this is, quite momentous. And they are telling you this is a problem and we need to solve it. Well, what does that mean to someone sitting in this audience? Because a lot of us are just low-level peons, right? Well, more work. Got to deploy V6 on hardware that doesn't quite work yet, with code that doesn't quite work yet, with customers who don't know what it is, and you're going to have to do it overnight. So business as usual, right? You guys are used to this every day. It shouldn't really be a big deal. But the thing is, the pressure here is going to be probably double what a lot of people have been thinking. You've probably all been working on some plan, maybe just in your research lab, saying it's going to take us this many man-hours to deploy V6 and this many thousands of dollars to upgrade equipment and all this other stuff. How many of you have done the same thing for what it's going to take to extend the life of IPv4 and how much work that's going to be to you? So what does that mean? Let's get down to the nitty-gritty, the technical details, not the lawyer speak on this. Large blocks aren't going to be available. Whether this is because the RIR has run out of large blocks or because you're buying them on eBay and they now cost, $6 trillion per IP address and you can only afford 3, whatever the reason is, there will be longer prefixes in the table. How should RIR policies evolve to handle this situation? Do we want a policy that says if you come ask for a /12 and the only thing ARIN can give you is 3,000 different little, /24s that come close to making that up? Do we want the RIR to do that? Is that good for the internet? It'll almost certainly mean more NAT. One of the quickest ways to extend IPv4 is to stop giving people blocks and give them one address instead. I have no doubt that there will be various ISPs in certain locations for certain reasons who in the near future will push their customers to be nearly 100% NAT. Some of you will have V6 only customers who will have a lot of trouble getting to the rest of the internet, particularly early on. And this problem actually will reverse at the end. Eventually you will have V4 only customers who can't get to the V6 internet. Gatewaying is a huge problem. We're going to touch on it today. There are, best I can tell, at least 10 different ways you can approach about half of the problem. There is no complete solution. And one of the most interesting ones that's come up with the legacy RSA is reclamation of address space. However, I don't think that's where the most interesting work occurs. Raise your hand if you know of a block, /29 or bigger, allocated in your database but not actually in use on your network. Yeah, that's probably all of us. So I have a feeling at some point in the future all of you are going to be asked to go through all of your allocations to your customers and go, are these actually in use? And it may get worse than that. If you're one of those companies, for instance, who sold a T1 with a Class C, people did that for a while. Someone might come to you and say, go look. Is this a customer who got a T1 and a Class C and decided to put up a NAT firewall to protect themselves and is actually only using one address? And if so, go renumber them into a /32 and recover those other 255 addresses for more customers. Reclamation at your own ISP probably will be the most painful. So what we've done here is we've put together a blue ribbon panel to kind of represent the entire food chain top to bottom. So let's see. So I have David Conrad here, representing IANA in this particular case. And if you look at any addressing thing, he's the guy hoarding all the address space. He's got all this reserve stuff. I don't know what he's doing with it. If you're looking for reclamation, this is the guy you need to reclaim from. No, he was just given it. It's really unfair.
And if you have any questions about that space, my email address is barbara.roseman@icann.org.
We have Paul Vixie down on the end. He's here representing the ARIN Board of Trustees. I hear he's got designs on taking over the entire internet. You can judge for yourself. We have Jason Schiller representing a large ISP, in this case Verizon Business. Probably most of you don't know that name, UUNET, MCI, WorldCom, yeah, MFS, pick your name. He represents them all, I'm told. We have Ron Bonica from Juniper Networks. He's the only guy up here happy, by the way. He's salivating this bonus he's going to get, because either way he wins, right? You got to buy new hardware for V6, or you got to buy new hardware to handle the bigger IPv4 table. And if he's really lucky, you make the wrong decision and you end up doing both. So he's the only guy up here happy. And finally, we have Mike Leber in the middle over here from Hurricane Electric. A little smaller ISP, but from an IPv6 perspective, a very forward-thinking ISP. Probably one of the most well-connected V6 ISPs out there today. So we're going to ask them a few questions, get their opinions on this stuff. Hopefully there'll be a little time left over that you guys can ask some questions too. So we're going to start here with IPv4 runout, the wonderful picture on here. And the first question is, do you guys believe Jeff? He's sitting right down there. Tell him if you think this is accurate or not. Is he even in the right ballpark? 2010, 2011, next year, 2030? Anybody want to comment? Go ahead.
So another individual who happens to actually be here has done similar projections, although using different models for the projections. And it's interesting, if you look over time, the individuals, Tony Hain is, I believe, standing in the back there. It's interesting over time how the two projections have actually been converging. I think they're probably within a couple of months at this stage. Initially, they were quite disparate, and I think on the order of a decade. But now they're down to a couple of months difference, so that sort of says something.
Yeah, 5 years ago, there was about a 6-year spread between Tony's projection and Jeff's projection, and now there's about a 6-month spread. And I would argue that the two projections are so close, and the window of error, the margin of error is large enough, is probably larger than the difference between their projections. So I'd say, for all practical purposes, they're in agreement.
Go ahead, sorry.
Even if the projections are off by as much as 5 years, the conclusion is the same. We have to start doing something now.
It's an excellent point. Probably the next question, because this is the one that we can't represent by a mathematical model, so it's only people's opinion. What do you guys think about the run on the bank? Are we all going to be good little citizens and just wait for this to run out? Or is everybody going to run out of this room and over the lunch break here start submitting templates willy-nilly?
I want to say that I don't want to say go ahead and make my day or bring it on or any of those sorts of things, but I will say that there are policies and there are pretty good teams in place, and in order to make a run on the bank work, you're going to have to lie, and if you lie to the ARIN staff, they will get mad at you.
I think that there actually can be a run on the bank scenario even without lying or exaggerating greatly. I expect nobody wants to be the ISP that goes to ARIN the day after we run out of addresses. And I suspect people will be looking very closely at their utilization, trying to reorganize their space, trying to make sure that, if at all possible, that they can request their address soon enough so that they're not in the position where they've waited too late and they can't get address space. And it's just like when it snows on the East Coast. Everybody runs to the store and gets their milk, bread, and eggs. so that they can buckle down for the snowstorm and, I guess, make French toast. I don't know. But yeah, I expect people to try and get as much address space as they can before they can run out without lying.
I know for anybody who's actually seen the slides, it's definitely part of the collective unconsciousness. So for example, when people are talking about projects that are coming up, they include getting address space is part of the process. Whereas in years past, that wasn't even an issue.
That's true. One of the biggest concerns is routing table size. And that concern's come up a lot in V6 in general because, right, if you dual stack, you got to hold 2 copies of the table. But specifically, what effect do you guys think runout will have on longer prefixes in the table and thus routing table bloat, either because, again, the RIR can't give out a longer prefix or because people are just forced to use smaller prefixes than we use today?
Here's one of the things is if there's ends up being routing table bloat, you're going to have to replace a fair amount of infrastructure, or at least customers are. The issue is most of this is a capital expenditure discussion because the people here are infrastructure operators, and the issue is networks. And actually, IPv6 deployment is easiest for networks, and networks have to be first. So the thing is what you're really talking about is decisions of what router are you going to buy when your capital purchasing cycle comes up for different pieces of infrastructure. And so the thing is that if routing table bloat occurs, then you're going to be put in a position of upgrading certain pieces of infrastructure a bit quicker. And it may be not necessarily just due to the amount of memory and amount of TCAM, but also potentially due to just convergence, because the route processor is going to have to process more updates. And as some of the data that people were looking at is a lot of times nowadays the convergence time is not related to some of the algorithms, but actually how quickly it takes to send the table, and and so on.
Sorry about that. So I'm curious, how many people here were actually involved in network infrastructure in, say, 1996, around that time frame? Raise your hand. So of these folks, how many people had the experience of having to watch their routers fall over because their routing tables weren't large enough to support the tables? Yeah, memory, like when we broached the 22K boundary on the Cisco AGSs or whatever happened to be running in the infrastructure. So some of these folks already know what a likely scenario is going to be as we get to a point where the routing tables are growing faster than our ability to cycle out hardware, replace it with new hardware. People are just going to deploy filters to protect their own infrastructure. Having a router fall down is sort of a bad thing, and you want to stop that from happening, so you do whatever is necessary. At least that's how I would view things. But then again, I don't run a router anymore. So.
Yeah, I think that there's significant possibility of increase of routes in the routing table. If everyone goes to dual stack, we're going to nearly double the internet table. On top of that, we've got, 100 legacy /8s. If all of those deaggregate to /24s, that's like 6.5 million routes. Clearly, some of those /8s are probably in use and are not going to get deaggregated and resold or reused. But, I mean, the potential is there. And the other potential is that the RIRs might not have large, /20s to give out. They might start giving out smaller blocks, and it's theoretically possible that in the near future, a new network that's being built that has no addresses might only want one IPv4 address so that they can NAT all their v6 hosts behind it. And presumably, we could get stuck routing IPv4 /32s.
So, being at ICANN and sitting on the outside of anything actually real, I've been watching some of the discussions that have occurred in various venues, and one of the things that I have to admit confuses me somewhat is, I believe at a previous NANOG or at a RIPE meeting, Your favorite router vendors have gotten up and explained how they have routers that now can handle like 1 million routes, within a few years can handle 2 without any change of technology, and up to like 10 million routes. When I talk to some operators, they say that's just crap, that it might work in a lab, and in reality that's never going to happen. The convergence times will cause mass hysteria and cats and dogs living together and that sort of thing. The discontinuity there is very confusing to me, because I would assume the operators would be talking to their vendors and saying, you're telling me crap, but the vendors have been getting up and saying, well, not to worry, a couple of years, 10 million routes, what's the problem? Does anyone have any view on that?
I'll certainly inject my own view, and that is, I'm sure the operators have boxes that can do lots more. How many of you can afford them? How many of you have swapped out every box on your network in the last 3 months? Sure, we'll go to the mic here.
Randy Bush, IIJ. First of all, what they're saying, and they stood up at RIPE together and said it, is 2 million routes today and 10 to 10 million routes in a few years. Secondly, that's BS. Thirdly, if only one can do it, it does me no good, because I'm not going back into the single vendor universe ever again.
Jeff?
Jeff Houston, APNIC. I'll try and be very quick. There's 2 separable problems in the routing space. It does appear that the update load is actually independent of the size of the table. What we're finding is there's a table size problem. And secondly, there's an update problem, but the update problem is a small number of folk being intense rather than everyone just doing cosmic radiation. If you conceivably had a BGP table with 3 million entries, it doesn't necessarily mean that the update load would be 10 times what you have today. It might even be the same level, because the update rate and the table size are separate artifacts here. That's all.
So if you're going to need new hardware, when you go to get it, make sure it supports V6. Tip.
Probably good advice.
Leo?
Yeah.
One other note, there will be a panel during tomorrow's public meetings at ARIN with a topic that overlaps this one somewhat, and Tony Lee from various router vendors will be coming to address this question at the level of sort of what are the physics of routers and routing tables. So if you can possibly stay around an extra day, then we'll get some additional information on that question.
So here's a loaded question, probably more for the ISPs. See if we can get some speculation here. Over the next 2 to 3 years, as we approach this run out, what do you think gets more attention? Do you think there's an increased use of NAT in V4? Do you think there's just reclamation of underutilized space in your own networks? Or do you think people actually migrate to V6? Where's the emphasis?
I would like to think that people take a V6 migration seriously. I think many of the people who can use NAT already are using it. There's a lot of negative side effects with NAT that I'm sure everyone is aware of. I really hope people take a look at when V4 exhaustion is going to occur, look at how long it's going to take for them to certify and roll out V6 and upgrade hardware if need be, and start that in time before we actually exhaust the V4 pool.
If you're a network operator, and separate from the access discussion or broadband and whatnot, if you're actually a network that's providing service to people who actually are responsible for the administration and upgrade of their end user systems, set-top boxes, NATs, et cetera, then the whole migration is extremely simple. I mean, it's just a matter of planning when you're going to buy hardware that supports it. And I mentioned it already, and it's, it sounds ridiculously trivial, but there are people who are buying hardware right now that doesn't support V6, and you can ask a question of, do you want to be in business in 5 years? Just, you're going to have to buy routers. How often do you buy routers? So if you're buying routers in the next 5 years, better make sure. And so, you know, for a network operator point of view, the migration is really straightforward, and network operators have to provide, you have to have the capability in order to get the customers. The customers that either are hosters or access networks or broadband providers and so on.
I think that the answer might be all of the above. Let's say for a moment that you're an ISP that already has hardware that can handle IPv6. If you were to start a concerted effort today to migrate your network and all your customers to V6, it would probably take a few years. And that brings us dangerously close to what Jeff says doomsday is. So probably we're going to need to do something to delay doomsday to give us some time to do that migration.
So here's one that Steve Ryan will probably... Oh, sorry, we got somebody at the mic.
Okay, Tony Hain. One additional comment. I agree that it's going to take a fair amount of time, and we're going to see a combination of all of the things you ask about. It's not going to be one or the other. But one of the things that I think I find striking is when I talk to content providers, they all say, I'm willing to think about V6, but where's the network? And I talk to the service providers, and they're saying, there's no point in me doing it until there's content providers. Please talk to each other. Don't stand around talking to the vendors saying, make your gear work better so that they're willing to deploy it. Go talk to the other guy and get him to do his part, because unless the content providers and the service providers are on the same page, we're not going anywhere.
I'd like to put Leo on the spot for a minute, because he said something at a previous meeting about how it's the end users that are actually going to drive V6 adoption. Because I think what a lot of the ISPs are saying, until customers start coming to me and saying, we're going to pay money for V6, or until they start saying, we're going to leave and go with somebody else unless you support V6, there's not really a lot of motivation for the ISPs. And part of the problem is, a lot of this does require hardware upgrades, which is an expense, and there's no return on that investment in the near future. So I think the game that everybody is trying to play is to do a minimal investment in V6, do the certification effort, do the testing effort, make sure that all their ducks are in a row, and wait until the last possible minute, and then start the migration in time for you to be able to build a just-in-time V6 network. So I wanted to kick it back to Leo and ask him, do you still think that it's the end sites that are going to drive V6 adoption? And if so, is there really going to be a demand from end sites prior to V4 exhaustion and prior to them being forced to build a V6 only network?
First of all, I will point out that NANOG is a great forum for content providers to talk to ISPs. Just don't ask them for free peering. But to directly go to that question, I certainly think, and the next slide will be even more relevant for this if some of the people in the room involved want to consider a response, that if end user networks, and by that I actually mean individuals, residential DSL, cable modems, dial-up, pick your WiMAX technology of choice, etc., were to deploy V6 in a dual-stacked environment, that would greatly accelerate the interest in both other ISP networks and content providers in providing the service. So that's where I see the focus on end users. If those people don't have V6, the rest of the networks and the content providers having it, you can't get to anybody. So, Cathy?
Hi. I guess I just really disagree with that. I think that V6 is something that is completely transparent to somebody sitting in their house behind a cable modem. I mean, there has to be a killer app that can only be reached on V6 for them to care. They're not going to ask for V6. They're going to ask for porn or, some new game or, some sort of functionality. They're not, unless the killer app for V6 is I want more than one IP address. But I just don't see why someone in their home is going to come to an ISP and say, oh my God, I have to have IPv6. I mean, maybe I'm out there, but I just don't see that happening.
I don't think they would. I think it's the access providers are going to be in a situation, if you look at ARIN allocations, some of the people who do cable modems, DSL, that kind of thing, are the biggest address space holders. They're going to be the first to come back and say, I need a new /8 for 20 million more customers, and be told no.
Right, but that's not the person in their home saying, oh my God, I have to have that. No. That's the ISP saying, I need more address space.
No, I agree. I agree. Yeah. Yeah. Oh, yep. Over here.
I would like to make a comment about upgrading the routers. Sure, this is a problem because routers are expensive, but in the grand scheme of things, this is not the biggest problem. The software in the back office and all of this is the real problem because it takes a lot of time to get it. And this is something that we, in this community, most of the time forget because we are network engineers who tend to think problems in terms of layer 3. But I really think that this IPv6 story is a layer 7 and 8 problem. It's layer 7 because you need to get all your application ready, and it's layer 8 because you need to convince the finance people that they need to spend money now that will bring return on investment a couple of years later. So this is really the way we have been trying at least to approach this problem internally, try to make sure that all those applications get ready, because buying new hardware, installing new hardware, this can be done in just a couple of months. Getting all your back office ready, it can take years.
We'll just take the questions at the mic now.
Hi, I'm Roque Ariano from Tel. One of the things is, you talk about end users, and when, as a DSL service provider, you go to the web, you go to the presentation, the workshops, and trying to find out material of, okay, how do I build my service? How I'm going to deliver the IPv6 service to the customer. You realize that there's a lot of material out there how to route IPv6. And there's a lot of material about, okay, we know PPPoE has a problem, we know DHCP, prefix delegation. How are we going to get our old gear in PPPoE, the new gear, how we're going to authenticate users? All of that infrastructure is extremely important. And there's not a lot of training on that. We go to the IPv6 training workshops, whatever we do, and it's always about routing. And there's much more, as I will say here, than just routing, okay? We have to change a lot of stuff, a lot of databases, but also we have to change, there's not a lot of implementation on how to deal with the all authentication in PPPoE, radius, and the HCP. The second thought is like trying to do that in a third world country. We realize that vendors there, and they have no idea. They skip V6 training. And that's extremely tough. You try to open an IPv6 issue, and you get 6 months until you deal with somebody who knows what it's about. And I'm talking about all the vendors. I got 5 vendors, no idea.
Last question.
Just more of a comment or observation. This is a lot like, in some respects, Y2K, where things were going to break, and it was going to be the end users who were going to have to drive the problem. But there were enough forward-looking businesses that realized, oh, wait a second, if our stuff breaks, that affects us too. I think that there may be another hidden driver, which is businesses that use the internet for providing services to their customers, i.e. over the web, and I think they may actually be the demand customers that drive service providers to deploy V6 ahead of the demand for end-user content.
Keith Mitchell, ISC. Obviously there's been a lot of talk about markets as a way of incentivizing efficient use and potentially extending the life of IPv4 address space. And we kind of have, if we're going to set up a market, we kind of have a blank sheet of paper to do that with. I'd be interested if the panel members think that it's feasible to structure such a market in a way to incentivize IPv6 deployment over IPv4.
That actually leads wonderfully into my next question, and that was going to be for the panel. Should IP addresses be bought and sold? Will there be a black market, a gray market? Should RIRs set up a white market for this? And will all this do drive up the price of IPv4 and thus incentivize people to move to IPv6? So what do people think about a market?
So let me start with the less controversial second half of that question, which is trying to extend IPv4 and what the impact of that is. I think functionally what's going to drive IPv6 adoption is IPv4 exhaustion. And when there are no more IPv4 addresses and you have to build a new network and you have no addresses, you'll be forced to build a V6 only network. The question is, how do you define exhaustion? And a lot of people are looking at how many IP addresses are left in the IANA pool or the RIR pool or your upstream ISP's pool. And I think that's really the wrong way to think about exhaustion. I think the right way to think about exhaustion is, when does it become too difficult or too expensive for me as an end site who's building a new network to get v4 addresses? If the addresses are too hard to get, if I have to wait too long, or I have to spend money that's beyond my capabilities, for all intents and purposes, for me, v4 exhaustion has already occurred. And if the market is going to price the addresses high above many of the end sites that need them, then exhaustion has already occurred, and they will be forced even earlier to adopt v6.
Anybody else want to comment?
So, I want to disagree with my fellow panelist on one minor point. The exhaustion of v4 driving the adoption of v6 is a common theme through a lot of these debates. You can see it on PPML every second day. I think that if, do a little thought experiment with me, if the technology were somewhat interoperable, such that you could build a network using v6 today that would interoperate with the existing v4 network in a way that your customers could tolerate. Forget about whether it's transparent or not, just say, you know, if you could still sell services that way, a lot of people would switch to IPv6 right now, just to get it over with. It's the fact that you have to continue building v4 for the next couple of years, and maybe you'll do dual stack and maybe you won't, but you have to build v4 right now if you want to grow. That is causing people to say, why am I bothering with this v6? So the truth as I see it is that it is the inability of other people to continue building new v4 networks that will cause each of us to then start building v6 networks, which goes back to a long-held premise. The biggest problem on the internet is other people's networks.
I'd also like to debate with Jeff's definition of when IPv4 address exhaustion occurs. You say that it occurs when I can no longer afford to buy address space. I think it occurs when either I can't afford to buy it or the people I need to communicate with can no longer afford to buy it. As to the second part of the question about address trading, whenever a resource is scarce, people tend to trade it for money. Now the question is that going to be a black, gray, or white market? It depends on policy.
So with regards to black, gray, or white markets, I believe, or at least I have experienced, the existence of either a black or a gray market, depending on your definition, that exists today. It has existed for quite a long time. I have some significant skepticism that it's going to magically disappear when IPv4 runs out. One of the larger questions that the RIRs have to face is the future, are they going to continue to be involved in the definition of IPv4 address policy? And if so, how? Since the tools that they have to use today will no longer be available to them. With regards to the definition of IPv4 runout or exhaustion or depletion or whatever you want to call it, one thing to remember is that everyone on the planet has a very large amount of IPv4 address space available to them in the RFC 1918 private space. It's difficult for me to conceive of a scenario in which someone will actually deploy a real IPv6 only network, because they will instead be using IPv6 as a way of gaining access to the outside world, using IPv4 internally, potentially with IPv4 and NAT, to initiate connections to sites that provide IPv4 only services. The question that really ISPs need to focus on is how are they going to continue to enable IPv4 services over the network. And that's particularly relevant to content providers because, right now the vast majority of end users have IPv4. They don't know that they have IPv4. They don't know they have IP. They might know they have domain names, but that's a stretch. They have the web. And those folks are not going to be interested in IPv6. The content providers, in order to continue providing services, will be providing those services via IPv4, since most of the end users will be connecting via IPv4 plus NAT. So the question to the Internet Service Provider community is, how are you going to transit IPv4 traffic when you can no longer connect customers with IPv4? You have to use IPv6.
In 2001, we experimented with writing application layer gateway NAT PT stuff. Because we predicted that, it sure was way ahead of things. And honestly, it's on a shelf somewhere in some big warehouse. But the point of it is that we were experimenting with the idea that you make a box that checks to see if a site's available via v6, uses that. If that's not, go to v4, et cetera. And because there's anticipation for both isolated v4 networks and isolated v6 networks during the transition. So, the vendors are going to make this there's potentially going to be open source, the Linux boxes already with giggy interfaces. It's going to be a horrible glue. People will be buying the equivalent of 10 gig NAT PT stuff.
That raises an interesting question that we did have in the hall with the vendor rep the other day. As far as I'm aware, neither Cisco nor Juniper makes a card you can slide in a high-end router and does 10 gig of NAT. I do wonder who will be first to build such a thing. That may be an interesting way to corner part of the market. Yes, Randy?
Randy Bush, IIJ. I'm of the opinion that tunnels like graves are holes in the ground. That what will happen is that NAT PT, and we're going to chop and slice and dice the v4 address space so that all those end sites can have one little address, so all their v6 can go over the dual stack backbone. We have choice. We don't have to do that. We cannot go to v6, and we can have 10 jillion v4 NATs hiding v4 address space and having one little thingy and going over the v4 net. The first one can eventually go away. The second one cannot. Okay? I wish it was otherwise. I assure you I do. But I think those are our choices.
Do we have one other comment? Let's do that quick and we'll move on.
Yeah, Joel Yeagley. 10 gig NAT boxes exist. Talk to your firewall provider. And it's not the line rate, it's actually the connection tracking that becomes expensive in that device.
So the next question I actually gave to the panel, but I think I'm going to throw it out here to the audience, and we'll get a little show of hands, wake you up, make you move a little bit. First question I'd like to ask all of you from a show of hands. How many people believe their customers are adequately aware of IPv4 runout? Raise your hand. Yeah, not seeing a lot of hands. Hopefully we'll get a few more with this one. How many people believe their customers are adequately aware that IPv6 is coming? A couple. Okay, that's better. Let's see if we can get this up even higher. How many people think your own company's leadership is aware of IPv4 runout? We're getting somewhere. And last but not least, how many people think your own company's leadership is aware that IPv6 is coming? Hopefully most all the hands. Yeah, we're all awake. Okay, very good. This next slide, I said I wasn't going to read the quotes, and I won't. I do have to apologize to Jason for this one ahead of time. However, it was way too good of a quote and way too apropos of this particular situation. So I'll give you a moment to read that. So the neto thing that we want to talk about here is the actual v6 deployment side of this, at least give it a little bit of discussion so we can move on to ask a couple questions about the transition. And the first question is the one that everybody talks about the most, so I don't think we need to talk about a lot, but it does need to be asked. Is IPv6 in all the hardware and software that you need it to be in today? What's the biggest hole in that? Anybody want to comment? We heard from the floor earlier about management and provisioning systems and things of that nature.
Actually, for us, since we're a network service provider, the back office stuff for us was limited to just changing our v4 allocation tracking stuff to also take v6. And some of our automatic configuration management stuff, for example, for setting up peering sessions to take v6 sessions as well. So for us, that was the cheapest part of it. But of course, we're just keeping track of addresses. Then there's that's the layer 7 aspect of it, as you was mentioning. And then the layer 8 aspect of it is training your support people and making sure all the network engineers are fully expected to be dual stack aware.
Okay.
So the tickets get handled correctly.
Randy?
Randy Bush, IIJ again. At least you're getting me from the other side of the room. ISOC has a wiki that goes all the way from layer 0 to layer 8 with details about the good things and the bad things happening at each of those layers by equipment, by so on and so forth. And you'll get that URL, unfortunately, if you listen to my preso this afternoon.
Cathy?
Hi, Cathy Aronson again. I guess people have been saying, vendors have been saying that IPv6 is in my equipment for a really long time now. But if nobody's actually using it in any kind of volume, then you don't really know whether it actually works in the equipment. And I think even with the routing table stuff, we see there's a ghost problem. It's a bug. It's actually been going on for 5 years. And, it finally got fixed. So just because a vendor says that their equipment does v6 doesn't actually mean that it does v6.
Avi Friedman with Akamai. I think there's an interesting third category of things that one needs to consider with IPv6, which most people on the panel and most people in the room probably consider, but often gets left out of the discussion, which is the provisioning systems and the back-end systems and the monitoring systems, the billing systems. And a lot of people for a lot of people that I've talked to in networks, that's actually at least as much or if not a bigger problem than the staff training and, because their routers support it, their hosts support it. But how do you make the network work? You've got all this glue code, and a lot of it people haven't touched for a long time. There's a real big cost there. And so that's something I don't know whether the community can help. There are a lot of things which we'd all like better tools for, but it's just something to think about in terms of the overall cost when you do an analysis.
RS, and then we'll move on. Oh, sure. Go ahead, RS.
Hi, Rob Seastrom here. To add on to what Cathy just said, I have a great luxury these days as far as my job is concerned, which is I'm designing a network from the ground up, and I have absolutely no legacy stuff. So I want to run v6 on day one. And I'm having conversations with vendors where they support v6 as a checkbox option for RFQs, and they kind of, the support gets shakier the more you look at it. And to underline some of the stuff that you said in your presentation, management over v6 may or may not exist. Oh, our stuff passes v6 packets, that's nice. It's okay in the core, it gets worse as you go to the edge. Switches, you can't telnet or SSH to the thing over v6. You can't talk SNMP to it. Oh yeah, well you can ping it, you can put an address on it. Everyone in this room, if you aren't demanding full support for v6 from your vendors right now, today, you are part of the problem, and you are going to be regretting not demanding that v6 support when all of a sudden you have to depreciate your stuff in 3 years instead of 5, or 5 years instead of 7, or whatever, because it ceases to be as useful as you thought it would be. This is like image size getting too big to fit in your flash. This is like any one of a number of other things that can cause your equipment to not do what you want it to do. And so everyone in this room, please think about your own best interests here and start demanding that from your vendors. Paul has his hand up.
So I'm going to cut off the questions for now, and Jason actually jumped in first, and then we'll get Paul.
Yeah, I wanted to kind of clarify that question quite a bit because I think there's a number of different questions in there. And I think the first question is, your network as it is built today, does all of its technology have V6 capabilities? And if you're a large ISP and you want to move all of your traffic and hardware, that means no Engine 0 line cards, no Engine 1 line cards, no Engine 2 line cards, and no 7513s. I know that there's a lot of equipment out there that simply, yes, does support V6, but not in hardware. And that's a very important distinction. The second question is there commercially available equipment today that supports V6? I think generally in the core that's true. On the edge, to some extent, depending upon what you need your edge box to do. Customer premise equipment, in many cases, the answer is no. If you're talking about DSL routers and cable modem routers, there's not a lot of support for V6 right now. Yeah, so I think that's what I wanted to say.
Okay. Paul?
So, Rob, there's a tricky part of Darwinian thought, and it may be tripping you up here. The companies who doubled or tripled their engineering and QA costs in order to provide rock-solid V6 support to go along with their V4 support are out of business. They no longer exist, or they were never funded. So I understand that everything is shakier than you want it to be, but it's only now that it becomes possible to run a company that's got that as part of its philosophy that isn't a badly run company.
My point is simply that 3 years ago I wouldn't have been advising people to be up in arms and be part of the push for this, because there was not the business case to be made for that. And it was better to spend your time on other things other than lab testing it and filing bug reports, which I do too frequently. Today, that no longer holds true, and the people in this room stand to lose if they are not part of the push for making things work better.
Even though I'll end up going swimming against the current on some of this. We've been doing interoperability testing for us, like consumer firewalls and stuff like that, just so we can write some white papers about what works and doesn't, et cetera, for the kind of like end user. And a huge amount of stuff both supports V6 and or newer customer devices like from D-Link or Linksys and so on. Basically out of the box, either, believe it or not, contrary to a lot of slides I've seen, past Protocol 41 for 6-in-4 tunneling and things like that, which, in other words, they're maintaining state just like they do for UDP. And the thing is that I've seen a huge amount of documentation that says, no, it doesn't work, and oh, that's going to be this gigantic problem and everything. And I don't think that 6-in-4 is scalable or necessarily a long-term solution, but, the thing is that it's already there, it works, et cetera. In Linksys, et cetera, and then and so on. With deployment, I've seen a lot of DSL providers and things like that that have V6 already deployed to the customers not even aware of it, and people doing testing where they come up and they're trying to do a tunnel on under Windows, and it turns out they already have V6 connectivity, and they didn't even know it. It's just because it's arcane and it's invisible, like somebody else was commenting about. End users don't care. But the point is there's already providers that have deployed this. So and then further, so in other words, there's people who have deployed it. It's working. There's CPE, this stuff that works. You have to pick it. You have to actually have the flag in your head of, oh, I'm going to check for this, and then, oh, hey, wait a second, I'll do some interoperability or acceptance testing, as part of buying it. But the other thing is, there's a huge amount. A lot of people say, oh, I'm going to do V6 when it's mature. V6 has been out for so long that there's a huge amount of open source packages. If you use open source packages for your infrastructure, for management, et cetera, all the stuff supports V6. It's already been out for a long time. So, you have to kind of pick. Of course, a package that has not been maintained since 2001 or something is not going to necessarily have it, but, there you go.
The other thing, too, that I wanted to point out is let's just not blame the vendors that they don't have V6 SNMP support and separate V6 counters for traffic. And there's also protocol issues here. Imagine deploying a router that's running V6 only. What do you use for your router ID? How do you terminate an MPLS LSP? I mean, never mind, how are we going to figure out how to do scalable multi-homing? So there's also some protocol issues here that have to be sorted out.
I hate to cut off the mics, but we need to move on because we're running a little short on time, so I'm going to move on to the next topic here. If we get some time at the end, we'll take a few more questions. One of the questions I think that's very important in the RIR community, and I wanted to bring up in this forum, is there's a lot of hemming and hawing over are we doing the right thing with IPv6 space, and there's certainly a number of people out there who believe current IPv6 policies amount to a land grab, that we're giving out blocks that are way too big. We've seen, /12s given to ISPs in IPv6 space. So the question is, do the current policies amount to a land grab? And if so, based on Cathy's presentation, why aren't you all taking advantage of it? If you can go grab some land right now, shouldn't we have 20, 30,000 prefixes in the table? So what do you think about current IPv6 policies for getting space?
I wish that instead of I mean, again, there may be some really good technical reasons, and there's some discussion over backwards compatibility, but if EUI 48 had been deployed instead of EUI 64, then you wouldn't be needing the /12s or 21s or 19s or whatnot. But the thing is that stuff doesn't, I'm kind of agnostic about it. I don't really, it's not like it's going to affect us in terms of allocations. It means compared to V6 compared to V4, if you said that there was an allocation for every network under V6, okay, what is that? However many active ASNs right now versus V4 with 230,000 whatever prefixes. So the thing is that you're going to have a massive reduction. So if this policy makes it so that there's sort of a land grab for certain larger guys, and then a few of the other people who actually run out have to go back for a second prefix, that means okay, so now you have an average of 2 prefixes per AS, which is still a massive reduction. So that's the only, that's the only thing that's imposing. But compared to V4, that's such a lower burden anyway. It's kind of inconsequential. It's just, if you were going to say, gee, what could be done, that would be the main thing. It's just, if there was a modification where there's a proposal for EUI 48. And it's a minor thing. It's really pretty much inconsequential, but if you were going to say, oh, gee, how could we optimize it? Oh, and the other thing is the proposals to do like 35s versus 32s, people couldn't comprehend, even though bit math may be easy for most of the people in this room, people can't handle 35 versus 32 in terms of bit math. It just mentally was too complicated. You'd see all kinds of mistakes back in the day. We'd see typos, people entering their addresses wrong because they couldn't do the math. And so the thing is that EUI 64 won because it's on a boundary. And any other proposals to do, 56, that's too complicated to even think about. Where's the boundary? So if there was going to be another boundary, EUI 48 would be great because it'd be moving it down one more colon. But that would be, it's, purely it's a end device thing. It's a stack thing. And there's been an implementation for Linux, but it's not really a router thing. It's more of a there's this FFE stuff inserted in the middle of EUI 64. That, anyway, this is minutia. This is really not pertinent to most people. It's just a minor thing of if you were going to be if you were already active in V6 and you're already you got it deployed and you're thinking of optimization, which we're not even to that point. This is what software engineer I know would call premature optimization, somewhat for people who are thinking about deploying. If you are active and you want to be involved in V6 and you want to be able, currently the end user allocation on a lot of slides is 48s for end users, and that's why you end up with people getting allocations of 19s and things like that. The issue is, for us, we allocate normal customers 64s and whatnot, and the issue is if a 64 was equal to 65,000 end networks, then a normal business could be allocated at 64, and then that would be the end of it. Currently, the normal allocation you would give a business that might have multiple networks would be a 48, because then that way they get 65,000, networks. So, end of story.
So, what about a year and a half ago, I guess, IANA allocated to the RIRs /12s. Those /12s were intended to be used using what's called the sparse bisection methodology for address allocation. And basically what that means is the RIRs had indicated that they had planned on allocating prefixes very sparsely in such a way as to allow them to grow by simply subtracting a bit from the prefix length as necessary. That is a good theory. In practice, I believe at this stage, one of the RIRs is actually doing that. And as a result, we actually have a situation where we're allocating fixed size prefixes with some reservation. I believe in some cases it's a factor of 8 reservation. However, some of the allocation sizes that have been done are, /18s, /19s, shorter than /18 in some cases. And they're the same number of those prefixes in V6 as there are in V4. So I personally believe that there are great areas of improvement that can be done within the V6 allocation policies to try to make them a little more rational. And then there's the question of end user allocations. Should end users provider independent be able to obtain provider independent address space from the RIRs so they can change service providers? If so, what is the maximum prefix length that they should get? There are arguments on both sides of that fence, and a lot depends on whether you believe the router vendors when they tell you they can route 2 million now and 10 million in a couple of years.
Another question that comes up when we talk about IPv6 policy in the RIRs is the question of whether or not we're creating an IPv6 swamp or not yet. And if we're not creating an IPv6 swamp, should we? Several people have stood up and said it would be a good thing that would spur on deployment. So are we creating a swamp? And if not, should we?
Well, most of the RIRs have a policy that supports IPv6 provider independent space as /48s that are not part of an aggregate that's pulled up by any topological upstream entity. This is a swamp.
Anybody else?
Businesses, big, Fortune 500 companies are going to multi-home in this story. So do you want that, it's a, again, this is kind of a policy decision.
So a swamp is inevitable? Is that what you're
saying?
saying?
So that people are going to announce the prefixes one way or another. So the only question becomes, are they going to come from providers or are they going to come from the registries? And is there a benefit for one versus, certainly it's a much more loyal customer, but, okay.
Not by choice. So in the original specification of IPv6 in 1996, I believe there was an assertion that there would be a total of 8,192 top-level aggregators in the routing table. Everybody on the planet would obtain address space from one of these 8,192 entities. When the IPv6 folks went to the RIRs at the time, we sort of looked at them like they had developed 3 heads. And wanted to chop all 3 of them off. The reality is that large-scale enterprises are very unlikely to be willing to accept anything but provider-independent address space, and any policy that does not take that into account is, from their perspective, a non-starter. The question as to whether or not a swamp will exist, well, yeah, a swamp exists now. I agree with Jason. Is a swamp necessary to get V6 deployed? In reality, if you want enterprises and content providers to actually move to V6, you have to give them something that at least isn't as offensive as it is in IPv4. Provider-independent address space is what many of them have now in V4. They're not about to give up the ability to change service providers. So the implication of that is, yes, there will be an additional swamp. With that said, hopefully the skies will part and a variant or Lisp itself will actually be deployable in my lifetime, and we can actually have some sort of separation of endpoint identifier and locator to enable the concerns about the swamp to magically vanish.
You can go if it's quick.
Yeah, Joel Yeagley. As far as I can tell, very large enterprises already qualify as IPv6 LIRs, or at least they've been successful in asserting that they are. And so I think, they actually fall into a rather different category than people who just want to multi-home, which I think are, by and large, what you're thinking of when you're thinking of swamp space.
I'm going to squeeze in just a couple of quick questions here on the IPv4 to v6 transition, so we don't get you out of here late. I think one of the most interesting questions to me on this, if we can get a couple of the panelists to respond, is how long do you anticipate running a dual stack network? Is this something that we're going to do for a year, 5, 10, 50?
At least a decade, if not decades.
Mike, you got an opinion?
20.
20? So we might be dual stacked for a while. A topic that came up in the hallway, and I think Mike kind of alluded to this earlier with his services thing, is if you end up with people on a v6 only network or even a v4 only network looking further down the road, do we see a return of so-called walled garden providers or other service providers? Whereas back in the day, we got our free CD and dialed into AOL and used their big proxy in the sky to access the web because they kept us safe. In the future, do we get a new CD from them allowing our IPv6 box to access their IPv6 proxy that gets us to the IPv4 internet because we don't have IPv4 internet? Is that a new service model that will come into being?
So this actually, I think, ties into some of the discussion that Dave Meyer was giving yesterday. I think there is a significant business incentive on the part of large-scale ISPs to try to drive up the price of internet service by adding additional services, and the walled garden model is sort of the ideal from their perspective, as long as you can control what your customers are doing. On the other hand, from the perspective of the end users, the end users who actually care about what services they're getting on the internet, they're going to eventually figure out ways of breaking through or jumping over or digging under whatever walls the service providers will provide. So I think the answer is that walled gardens will undoubtedly, from my perspective, spontaneously reappear, but they'll be a transitory thing in order to, just based on the simple economics of providing very complicated services via the economics of providing much simpler services.
So I think there's going to be two approaches to the solution of trying to get, well, three approaches, the solution of trying to get v6 only networks to talk to the rest of the network, the rest of the internet. The first approach is trying to get the rest of the internet into a dual stack mode. And we can see that clearly exhaustion is occurring faster than v6 adoption. So there's certainly going to be a gap there. The second possibility is getting at least one IPv4 address for every end site so they can set up some sort of NAT type box and hide all of their v6 IP addresses behind a single v4 address. Obviously, this is going to have a lot of the shortcomings of NAT. The third possibility is that there will be a third party that will offer a proxy service that you can connect to them over v6, and they will have one or more v4 addresses, and they will do the translation on your behalf. I'm not sure how well this is going to scale. I'm not sure how usable and stable this type of a solution is going to be, and how easy it will be to troubleshoot and maintain it running successfully. I suspect in the long term, people are going to move to dual stack. And with a throwback to the previous question, I don't think anyone who's got v4 addresses are going to be excited about turning it off. because I think it's going to be an S-shaped curve in terms of support of V6, and there's going to be some outliers for a good period of time, and nobody's going to want to miss an opportunity to talk to those folks.
And our last question, sorry. Light's right in my way.
Maybe this is a dumb question, but for my little set of users, there are a lot of these SOHO routers, small office, home office, or small office, home routers. And they've been a big problem for us a couple of times with various firmwares, and we currently have a problem with the Netgear model that's causing a lot of multicast storms. And I'm just wondering if we try to eliminate NAT, this Sunday talk on IPv6 seemed to indicate that that's one of the purposes, is to make NAT go away. Everything gets its own address, and they're all public. It just sounds like a big thing for the vendors of those routers to make them into just a switch instead of a router. But it'd be a good thing to get rid of the routing, because they don't do it very well sometimes.
That's true, unfortunately. So the last question, and this is probably actually the most important question to everybody in this room, and that is, will the industry be restructured as a result of this transition? That means, will you lose your job because you didn't do it right, and thus your paycheck? What do you think? Is this going to minor industry transition? Is this going to completely change who the big players are? How much impact on how the industry structured is this going to have? Come on, somebody's got an opinion.
So in 2 years, I'll be looking for a job because there won't be any V4 address space left.
You assigned some other things.
One or two, yeah. I think actually, if I were working at a regional internet registry, I would be wondering about my future job prospects, because most of the RIR business models these days actually derive a majority of the revenues one way or another from IPv4 address space. And particularly the allocation of additional address space. Obviously, there's going to need to be some change in business model as time moves on. What that change will be is an interesting discussion had by some.
So as an ISP, I would say that if you're looking at when V4 exhaustion is going to occur and looking at how long it's going to take you to certify V6, what sorts of hardware upgrades you need to do, how much that's going to cost, how long that's going to take, when you need to start in order to have V6 capabilities to offer that to all of your customers on the day that V4 exhaustion occurs, then you're probably safe at the company you're with. We're looking at that, and we're trying to do those calculations as best as we can and be a little bit on the conservative side. If you're not looking at when V4 exhaustion is going to occur, and you're not looking at how long it's going to take for you to adopt V6, and you're with a network that's of any size, you really need to start thinking about that. Certainly if you have, two 7200s and you're just planning on upgrading the iOS, good for you, good luck. But for the larger networks that want to do forwarding and hardware, that need to look at all of the hardware that they have in their network, that need to do upgrades, that need to do code certification, you really need to start now.
I'm sure that there's at least one or two people in the audience who feel that it's probably easier to polish off your resume than it is to get V6 in your own network.
One of the things I anticipate is with a certain amount of chaos and tragedy, there will also be a lot of opportunity for, just in the same way as there was Y2K Readiness Council, the Y2K Readiness Council and all the Y2K consultants, there'll also be a lot of IPv6 readiness consulting. So it'll be kind of right from the pan into the fire.
Actually, I did want to point out one thing about Y2K. The one thing about Y2K is it struck everybody at the same time, and everybody had the same implications if things broke in terms of financially how it would impact the bottom line. V4 exhaustion is different because it's going to occur at different times in different networks. So it's not exactly the same as Y2K. And that date is also not very clearly known, given a possible run on the bank scenario.
Here's a tongue-in-cheek comment. Well, I'm expecting that the the IPv6 Readiness Council will be set up when IPv4 is exhausted.
Well, we are running a little behind, so we're going to close it off there. I'd like to thank everyone on the panel for coming up here and sparking some discussion, and those who came up to the mics. And this quote probably is also very apropos in that it's you guys who are going to determine how this plays out. If V6 gets deployed a little bit quicker, or V4 runs out faster or slower, your own actions will greatly affect this. So as you go off to lunch, I hope that a lot of discussions occur. And I'm guessing there's a merit person with an announcement or two.